looked at the trace, okay, this is happening. So, well, if I get this from the BTS, this, say, sequence of hex values, I send back this sequence of hex values. And just by doing this, challenge response thing, he was able to get it up, do the TEI assignment, and bring up the OML and RSA layers, which is quite an achievement just from replaying these messages. Later on, he added a little bit of code for performing the location update. This is registering a phone to the network and paging a single phone. But that's about it. And it was very, very flaky and early alpha level quality. But it was sort of, yes, we can work with this BTS. This is how it looked like. It was a text, well, ported from DOS, a text program that was running on Windows. And you had, well, 8 different actions that you could perform. And that's about it. In November and December last year, I started this project called OpenBSC, which is what I wanted to start in 2006, but then I was too busy, where basically using the proof of concept reference code and the packet traces and all the knowledge from the specifications, we got to actually implementing this halfway properly. So we use the proper hardware drivers. We use the MISDN stack that's inside the regular Linux kernel. We had to do a couple of patches, but those are now in the mainline kernel as well. We had to learn the sockets-based API and come up with an architecture for the entire beast. Well, being the person I am, there's no threads, single select loop, event-driven architecture. At 25C3, we were able to, well, already have a minimal HLR. We could page mobile phones. We could configure our own network ID. So we could say, well, we are, Egypt or something like that. We did a lot of debugging and stabilization with more than 1,000 people, at least, trying to register the network. And we collected the IMSIs and EMIs of those phones, obviously. Because, well, this is one of the security or privacy concerns that we also want to make people aware of, that as soon as you have your phone on, anyone who claims he's a network without any authentication credentials can ask your phone, oh, please tell me your IMEI, this is the equipment serial number, and please tell us your subscriber number, which is on your SIM card. So there's simply no provision or no threat model for a rogue network attack in GSM. The network is always trusted. Only the phones can be evil. That's the mindset of the people designing the protocol. So now in this year, OpenBSC really takes off. We add more and more features. We have SMS store and forward switching. We have stable voice call support for full rate and enhanced full rate codecs. We support more than one transceiver per BTS. We support multiple BTSs. We have a Cisco-like console interface, so you can say configure terminal and that kind of stuff. And you can show the current channel configuration or send SMS messages. We added support for more BTS models, not just the BS11. And also, we interface to a traditional E1 now, so we can actually switch calls from an ISDN network into the GSM network and vice versa. Obviously, also tons of bugs and stability issues. Initially, we relied a lot on the phone behaving properly, which obviously is not a good idea because the phones are evil, and they have lots of implementation bugs. So you rather have to make sure that if the phone thinks, well, oh, the network has opened a channel to me, I will never close it again unless the network tells me to close it, then you should have a timeout and this kind of stuff. We had plenty of resource leaks, both of RAM as well as on-air channels that were allocated and so on. And we finally uncovered the last bits of the Siemens ABIS proprietary Siemens ABIS extensions in like 2 or 3 weeks ago. The status today is you can have a GSM network in a box. You can run it on any PC, no particularly high CPU or RAM requirements, as I will show on a later slide. It doesn't need an MSC, HLR, VLR, authentication center, or SMS switching center. It's all in one software. You don't need all these components. The capabilities so far, well, right now here we are in operation of a network with more than 400 users registered to the network. We have multiple BTSs. Each of them have multiple transceivers. Voice calls and SMS implementations are fairly complete. We don't have in-call handover. So if you establish a call, like let's say at the lockpicking tent, and you walk all the way up to, well, let's say the CCC, a dome, then somewhere in the middle, the call will disconnect because we don't hand over an ongoing call into the other cell. There's no GPRS yet and no edge yet because that's one of the highest to-do items in our priority. So in the future, we will separate some of these parts. We will support an actual A interface to use legacy BSC or MSC or traditional MSC implementations. And support for GPRS and edge, routing of calls between E1 and IP RTP-based BTSs, and also interfaces for stuff like injecting packets from SCAPI. For one particular BTS, I already wrote that. It's called IP access proxy, I think, or nano BTS proxy. I don't even remember what I called it. But there's a proxy now which you can basically put between the BTS and the rest of the network. And with that proxy, you can inject packets both to the network and to the BTS. And to the BTS means also to the mobile phone. So using that proxy, you can send, for example, fuzz packets from SCAPI into the interface and fuzz either the network or the mobile station, which, as far as I know, on GSM, nobody has ever done, at least not publicly. Well, that's certainly a lot of fun to be had. Like right now, for example, all the phones that are logged in our network, obviously, since we are the network, we can also send them some random crap and see how they behave. We're not doing this, at least not intentionally. Our implementation might be broken, and we might send a packet that your phone doesn't like. I'm sorry for that. Well, if you experience any problem, you can come to us, and we will see if we can debug that using packet traces and see what's actually going on. But we could, and that's sort of the whole point of this demonstration is, somebody buying a 300 euro unit from eBay and using his brains and publicly available specification can run his own GSM network. And since there is no provision against rogue networks in GSM, he can pretend to be your network operator or anyone else's network operator, and can do all kinds of tinkering with your mobile phones and with the data that you send through those mobile phones. So how does this HAR 2009 GSM network look like? Well, first of all, as I initially indicated, GSM is a licensed spectrum. You cannot just, well, you can, but you will get a lot of trouble if you just put up an antenna and start transmitting, because you will be interfering with some commercial operator, and not only that, you will also violate law. And since the other operators had to pay billions of euros in order to operate GSM equipment, they will be very interested in shutting down everyone who has not paid these billions of euros. However, you can apply for test licenses. You can say, well, we have this software, we have developed this GSM software called OpenBSC, and obviously we need to test it in order to improve the software quality. And therefore, we want a temporary test license, and that is what the organizers of the HAR event did. They applied at the regulatory authority of the Netherlands for a test